Now let's learn about dictionaries. Dictionaries are another very important Python data structure. While lists allow you to create collections of values, dictionaries allow you to create key value pairs. We already discussed dictionaries a little bit, but now we're going to discuss even more about dictionaries. So let me give you an example of a dictionary with just one key value pair. So dog equals, and then we're going to use the curly braces to create the dictionary, and I'll put name, and then I will put Roger. And just like any type of strings, we could make these single quotes or they could be double quotes. And the spaces here are not very important, but it's common to put spaces in between these things for better readability. And the key can be any immutable value. So this is the key and this is the value, and the key can be any immutable value, such as a string, a number, or a tuple. The value can be anything you want. So a dictionary can contain multiple key value pairs. So like for instance, we got the name, we can have age, and that's going to be 8. And you can access individual key values using a notation like this. So I can say dog, so I'm using the bracket notation. I can do name. So if I print this, it's just going to print Roger. And then again, I can use the single quotes too if I want. And it still prints Roger. And then you can use the same notation to change the value stored at a specific index. So let's say I want to change the name. So if I do dog, and I'm going to say that the name is now going to equal Sid. Now I'm just going to print the whole thing, and we can see the name is now Sid instead of Roger. So another way to get a specific element is to use the get method. So if I do a dog.get, and then I do name, so I'm going to try to get the name here, it's going to return Roger. So one good thing about this is that you can add a default value. Like, let's say I'm searching for color and it's saying none. It's giving it none because there is no color. But what if I want a default value? So I'm going to put comma and then I'll put brown. So now if it cannot find the color in the dictionary, it's going to return brown. But if it can find the color, like let's say color, and this is a green dog. Okay, it'll return green. So with the bracket notation that I was showing you earlier, you cannot have a default value. So that's one good thing about the get method. Now, you can also use the pop method to retrieve the value of a key and delete the item from the dictionary. Well, we also showed the pop method for lists. So, for instance, I can say get.pop, and then I will pass in name. And then right after that, I'm just going to print dog, the whole dictionary. So first we're going to get Roger, and then when I print the dictionary here, it's not going to show Roger anymore because we deleted it. Pop will return the item and delete the item. Now you can also use a method called pop item. The pop item method, well, let me show you that one. Pop item, it's going to retrieve and remove the last key value pair inserted into the dictionary. So in this case, it should be color. So if I run this, it's going to return color green. And now when I print out the dictionary, it's not going to show color green because that was already removed. It removed the last item. You can also check if a key is contained in a dictionary by using the in operator. So we're going to try to find out if color is in dog. If there's a key called color in dog, we run that and it says true. Another thing we can do is get a list with the keys in a dictionary using the keys method. So if I do dog.keys, and then we'll run that, it's going to show the keys. So the keys are name, age, and color. We can see that it's inside this thing called dict keys. But we can also pass this into list, so we return just the list part. So now we can see it's just an actual list, name, age, and color. And then we can do the same thing with values. So instead of dog.keys, let's do print dog.values. We'll print that, and you can see we have Roger 8 green. We can pass it into a list to return just the list here, Roger 8 green. And then finally, if we just do items it's going to return all the items in the list, or all the items in the dictionary, and convert it into a list. So you can see this is the first item in the list, this is the second item, and then we have the third item here. So we can see each item of the list, each item of the dictionary is now in a list. And then, like a lot of the other things, we can use the length function, and I'll just put dog, and we can see that there are 3 items in dog. Now you can also add a new key value pair to the dictionary. So let's say I want to do dog food, or it doesn't even have to be a single word. I could put favorite food, and I'm going to say meat. And now we're going to print that. Let's see, what did we, oh, this was supposed to, I did that a little wrong. There we go, this is actually how you do it. You use the bracket notation equals, and then just put what it equals there. Okay, now you can see that we now have a new item on the list, favorite food, meat. And then you can also delete an item from a list, or delete a key value pair. So I'm going to, del means delete, dog, or dog, there we go. And this time I'm going to delete color. And I'm just going to use single quote instead of double quotes to show you that it doesn't really matter the type of quote. And now you can see we don't know what color this dog is. It's no longer a green dog. And then you can also copy a dictionary. So if you want to make 2 copies of a dictionary, you can do it like this. Dog copy, that's the name of the new dictionary. I'll do dog dog.copy, and that would be the new copied version of the dictionary. Okay, now we are going to talk about a new thing called sets. Sets are another important Python data structure. Sets are another important Python data structure. Sets kind of work like tuples, but they're not ordered, and they are immutable, so you can change them. You can also say that they kind of work like dictionaries, but they don't have keys. They have an immutable version of a set called a frozen set. So let me show you how you would create a set. So let's do names, and we're going to use curly brackets just like that, and just like that. So we have two names. So you can see the difference is a dictionary, you use the curly brackets, but there's going to be key value pairs. But this doesn't have key value pairs. In a list, it's just going to be a item after item like this, but there's going to be brackets instead of curly braces. So one thing about the sets is that they are not ordered. So sets work well when you think about them as mathematical sets. So for instance, we're going to create a set 1 with Roger and Sid, and we're going to have a set 2, which is just going to have Roger. And so you can intersect two sets. So the intersection of these two sets will be set 1 and set 2. So if I just print that out, print intersect, and then we can just run that, and we can just see what. So it's just Roger. So the intersection of these two sets are just Roger, all the items that they have in common. You can also also create a union of two sets. So instead of just calling this union, I'll put mod for modification, and so I can show a few different things with the same variable name. And the union symbol is just the straight line like this. It's not an I, it's just the straight line. It's on the same key as the forward slash backslash, one of the slashes. Now we're going to get every single item in both sets, which happens to, in this case, just happens to be the same as set 1. But if we change this one to the word Luna, just a different name, and now we're going to get each item in both sets, or Sid, Luna, Raja for the intersection. And then we can also get the difference between two sets. So let me change this back to Roger. And for the difference between two sets, I'll use the minus, and the difference is just going to be Sid. That's the only thing that's different between the two sets. You can also check if a set is a superset of another, and if a set is a subset of another. So how you would do that is, so we're just saying, like, is this greater than that, which means it has everything in the other set? True. Now if we put it the other direction, does this set have everything in this one? No, it doesn't. You can also count items in a set with the length function. That's pretty self-explanatory. I won't even show it to you. We've seen the length function so many times. You can also get a list from the items in a set by passing the set to the list constructor. So does this set have everything in this one? No, it doesn't. You can also count items in a set with the length function. That's pretty self-explanatory. I won't even show it to you. We've seen the length function so many times. You can also get a list from the items in a set by passing the set to the list constructor. So I'm just going to remove this, and we will do list set 1. Okay, so now we have a list of the set. And then you can check if an item is contained in a set with the in operator, just like the list and the other places we use the in operator. And then one more final thing about a set. A set cannot have two of the same item. So that's another thing that's useful about sets. So if I type in Roger, so now we have Roger, Sid, Roger. If I play this, we'll see it's only going to print Sid, Roger. It's not going to add the Roger twice to the set. So that's another useful thing about sets, is it makes sure there's only one of each item in the set. So if you have a list that has multiple items, you can convert it to a set, and then it'll just make sure there's only one of each thing in that set. Now let's talk more about functions. We already talked about functions in the last section, but we're going to do a review and then go into even more detail about functions. So a function lets us create a set of instructions that we can run when needed. And I'm just going to paste in a function. And again, the indentation, it can be either 4 spaces, 2 spaces, as long as it's indented the exact same amount. So functions are essential in Python and in many other programming languages. They help us create meaningful programs because they allow us to decompose a program into manageable parts, and they promote readability and code reuse. So this one is a function called hello that just prints hello. This is the function definition. So there's a name called hello, this is the name here, and then the body of the function, which is the set of instructions. And the body of the function is everything that's after the colon and everything that's indented one level on the right. So to run this function, we must call it. So I can just type in hello, hello. And then this is the syntax to call the function, and I can call it multiple times. So I can just copy this and paste it. And now if I just run this program, it's going to print hello 3 times. The name of the function is very important. So the name of the function is hello. It should be, function name should be descriptive so anyone calling it can imagine what the function does. A function can accept 1 or more parameters. This is something else that we saw before, but I can type in a parameter right here, and this becomes a variable that we can use in the function. So I can change this, and instead of printing hello, it's going to print hello, and then we'll just put name. And now I can call the function with the name, and I can actually call it with different names. So we'll do Bo, and we'll do Quincy, and then if I just play that, we see hello Bo, hello Quincy. So as you can see, we call the function by passing the argument. And again, you can use single quotes or double quotes here. It's better to be consistent, just always use single quotes or always use double quotes. But for teaching, I like to switch it up to emphasize that you can use either. So let me tell you about the difference between parameters and arguments. These 2 words, parameters and arguments, are sometimes used interchangeably, and it's common to get confused about the distinction. We call parameters the values accepted by the function inside the function definition, and arguments are the values we pass to the function when we call it. Also, an argument are the values we pass to the function when we call it. Also, an argument can have a default value that's applied if the argument is not specified. So let me show you how I would do that. So we have it named, so right now it always needs to get a name. Well, first let me show you what would happen if I called the function without passing the name. I'm just going to run that, and we can see we're going to get an error. Hello, missing one required positional argument, name. But we can make it so you can call this function without passing in a name, where it's optional. You can if you want. So I'm going to put an equal sign, and then I'm going to type in my friend. And just to make this consistent, I'm going to make this all double quotes. Okay, so this is now an optional argument. So it's you can pass in the name, but if you don't pass in the name, it's going to default to my friend. So I'll just run this again with that default value, and now it's hello Bo, hello Quincy, hello my friend, because we called this and we didn't specify any argument or parameter. And then we can also accept multiple parameters. So I'm just going to get rid of this default value, and I'll put age. So now we're accepting a name and an age. So we can now use both parameters in our function. So I can do plus hello name. You are, and we're going to add the age. And now it's going to be passed in as a number, but we're going to convert it to a string. So you are years old. And then I have to make sure to add a space in here. So there'll be a space this word, then the number, then a space, and then years old. So I'm going to now have to pass in the number. And now I can run this function. Now, it's showing the red squiggly lines. Sometimes the red squiggly lines will appear when it's actually correct. So what am I doing something wrong here? Oh, I need to put the parentheses. If the red squiggly lines appears when it's actually correct, they'll go away usually within a few seconds or if you hit enter. So that actually was a problem. I forgot the parentheses at the end. So you can see this is what the whole function looks like if it's all on one line, but I'm just going to move that over. So, hello Bo, you are 39 years old. So we've used the name and the age. So parameters are passed by reference. All types in Python are objects, but some of them are immutable, including integers, booleans, floats, strings, and tuples. This means that if you pass them as parameters and you modify their value inside the function, the new value is not reflected outside of the function. Now, let me just give you an example of that. So if I'm just going to paste in some new code here, and we can see we have this function called change, and we're going to pass in this value. If we pass in this val variable 1 to the change function, and we set value to 2, well, then we're going to print the value and see what happens. And you can see it's now just 1 here. So it didn't change the value. So what we change inside the function doesn't affect anything from outside the function. And then you can see we have these orange squiggly lines here. Local variable value is assigned but never used. It's just showing that actually this isn't really doing anything. Once it's inside the function and when we change it, it doesn't change anything outside the function. So if you pass an object that's not immutable, you do change one of its properties and the change will be reflected outside. So this was mutable. This is immutable. An object that would be mutable would be like a dictionary. So if I change this to a dictionary and I put name and I set it to Bo, but then inside the change I do value.name, or not, I'll put the brackets, value name, so the key of this dictionary, and I set that to Sid, and I run this, we'll see now the name has changed to Sid. So we used the change function to change name to Sid, and now it actually is changed because a dictionary is mutable. So a function can also return a value using the return statement. So I'm going to update this whole thing and talk about return statements. A function can return a value using the return statement. So it's going to return this name that we then can continue to use in our program. And it doesn't have to return name, it can return anything that happens inside the function. And when the function meets the return statement, the function ends. So you can have a return statement and have code after it, but it will just end. Like for instance, if you have the return statement in a conditional, like in an if statement. We can also omit the return value. So it's just going to end the function and not return anything. So I mentioned having the return statement in a conditional. So that's a common way to end a function if the starting condition is not met. Like for instance, if we update the function to this, so if not name, return this. So if not name, return, or else, you don't even need an else because this will just end the function and you don't even need an else. This will happen if there is a name. Now, we just said that you have to pass in something if you don't have a default value. So the way to get to that would just be to call the function with false. So if we call with false, then it's just going to return. It doesn't do anything. But if we call it with Bo, then let's see. Hello, Bo. So you can also return multiple values by using comma-separated values. So, for instance, I'm just going to take this part off here and then add a return statement. Return, and then I can return the name. I can return Bo, in case that's not the name. I can return 8, and then I can call this, and I'm just going to call this with Sid, and we can see what happens. Now, it doesn't actually print what's been returned, but if I print this, here we go, then we can really see what happens. So in this function, it's going to print this, but now we're also going to print what's returned. So let's see what that looks like. So this is when we print what was returned, it looks like this. So it's Sid, Bo, 8. So one thing related to functions and also related to other parts of Python is variable scope. So let's look at this. We've declared a variable up here, and when you declare a variable, that variable is visible in parts of your program depending on where you declare it. So if you declare a variable outside of a function, the variable is visible to any code running after the declaration, including functions. So we call this a global variable. So we've declared this before the function, so we can now access it inside a function and also outside the function. So if so we can see 8 and 8, and it shows right here what it's going to show in the console here. But if we declare a variable inside a function, let me give you an example. If we declare this variable inside the function, I'm just going to move it down to here. Now it's a local variable, and it's only visible inside the function. So let me just delete this because it's not actually going to be doing that. So if I run this, we're going to see there's an error. Name age is not defined. We're trying to print the age here, but since the age was declared inside the function, it's not available outside the function. It's only available inside the function. So you just have to be aware, sometimes there's local variables that only apply inside the function, and there's global variables that can apply inside a function and outside a function. Okay, now let's look at something else with functions, and this is nested functions. Functions in Python can be nested inside other functions. A function defined inside a function is visible only inside that function. This is useful to create utilities that are useful to a function but not useful outside of it. So you might ask, why should I be hiding this function if it does no harm? Well, one, because it's always best to hide functionality that's local to a function if it's not useful elsewhere. Also because we can make use of closures, which we'll talk more about later. So look at this example. So we have this function talk, and inside the function we define another function called say. And then what we do is that we can call that say function inside the function. And so the way this works is we pass in the phrase. So here's the phrase, and the phrase is I'm going to buy the milk. And here we split it. So split is a way to create a list out of this string. So we have this string, but it's going to split it on every space. So it's going to create a list of each word individually, and then we're going to run this loop. More on loops later, and we're going to, for every word in the words list, we're going to say the word. We're going to say the word. It's just going to print the word. So if I just run that, I am going to buy the milk, and every time it prints it on a new line. So this would just be an example, because we're never going to want to use the say function outside of the talk function, so it's better just to put it inside the talk function. And then I'll just paste in another example here. If you want to access a variable defined in the outer function from the inner function, you first need to declare it as non-local. So we're using non-local here at non-local count, and this allows us to access this variable that was declared inside the out. So this is the outer function count, and we have this variable called count, and to be able to access that variable in the inner outer function, we have to call it non-local, or we already talked about variable scope, and if we didn't call this non-local, then we could not access the count variable from inside the function. So like for instance, I'm going to run this, it's going to print the count, which is just count plus 1, it's just adding 1 to this number. That's all the function does. But if I take off this word non-local here, and I run this, we're going to get an error, because it doesn't know what count is. It doesn't know that we're referring to this count in the inner function. So let's just put that back on there, and then it should work again. This is especially useful with closures, which we're just about to talk about. So closure is a special way of doing a function. Function in Python, if you return a nested function from a function, that nested function has access to the variables defined in that function, even if that function is not active anymore. So let me show you an example. I'm going to paste in code that'll be very similar to this code, but just a little different, and then I'll explain it. So now instead of count, it's a counter. So we're returning count from this nested function, and from the outer function, we're returning the nested function. We're returning the increment function. We're returning the nested function. We're returning the increment function. And then here, instead of just calling the function directly, the outer function, we're assigning it to this variable. And now we're going to print, we're going to call this variable, which is the returned inner function. So we're basically calling the inner function, and it's still going to, because we're calling the inner function, it's not going to reset the count to 0 every time, and it can keep track of that value. And we have this using a comment what it's going to return, but we can also run the program and we can see 1, 2, 3, just like that. So we return the increment inner function, and that still has access to the state of the count variable even though the counter function has ended. So let's move on to because we're calling the function directly, the outer function, we're assigning it to this variable. And now we're going to the outer function, we're assigning it to this variable. And now we're going to print, we're going to call this variable, which is the returned inner function. So we're basically calling the inner function, and it's still going to, because we're calling the inner function,